Okay, so this is the first video. I'm going to ask you again to bear with me as there might be some technical problems since this is the first video that I'm making. I do want you to know that I found it very hard not to teach to a live audience. So courtesy of my nephews, I was able to find an audience that was very willing to listen, and I wasn't all that happy with the participation in our class, so maybe they might even participate more. Not sure. Okay, today we're going to be doing graphs of polynomials. So let's get started. I'm going to pick up right from where we left off. If you remember, the last thing that we studied was increasing and decreasing of functions. So let's go into Desmos. If you have not used Desmos, this is a really great resource for you. It's desmos.com/calculator. If you just go to desmos.com, you can click on the graphing calculator and you type in your function here on the left and it will graph it for you. So you can check your work, you can look at different graphs. It's a great resource for you to use, particularly when we get to trigonometry. So let's just quickly review a couple of the things that we talked about in the last lesson. So if you remember, we look at a graph going left to right, and we talked about increasing and decreasing functions. So if we look at the graph from left to right, we could see that over here, the graph, meaning the y values, are decreasing as we go left to right. So we would consider this decreasing. And then here we see a nice turning point, and that turning point is called a minimum. It's a relative minimum instead of an absolute minimum. A relative minimum is where it goes from decreasing to increasing. So here we go from decreasing, we can see that we're turning around, and then we do go to increasing as we go left to right until we reach another turning point. So this turning point is also a relative maximum. This relative maximum, it's relative as opposed to absolute. So we call it relative when it's not the highest point in the graph or the lowest point in the graph. So we could see here that even though this is a turning point and it goes from increasing to decreasing, it's not the highest y value in the graph. We have lots of higher y values right here. Okay, and this goes from increasing as we pass through the turning point, we start decreasing again, and this just keeps on going forever. So actually in this particular graph, there are no absolute minimums or maximums because we do go from negative infinity to infinity. Okay, if we take a look at another graph, sorry about that. If we take a look at another polynomial, so if we look at this polynomial, we have from here, we are decreasing left to right. And then as we approach our turning point, so here's our turning point, we go from decreasing to increasing. This is a minimum. And this would actually be called an absolute minimum because it is the lowest point in the graph. And it's okay, you could see another minimum over here. It's okay to have two absolute minimums, that's fine. So, because both of these have the same y value, so that's all right. So we get to our turning point, we were decreasing up to that point, now we're increasing again. And over here, we reach another turning point where we go from increasing to decreasing. So this is a maximum, and this is a relative maximum. It's not absolute because we have lots of y values that are greater than this particular y value over here. Okay. And we can look at one more. We're just going to look at this one here. And here we can see we're increasing. Then we have this turning point. This would be a relative maximum because there are y values up here which are much higher. Then we go to decreasing. So increasing to decreasing is a maximum. And now we have decreasing to increasing. So you can see that as we go left to right, if you look at the cursor here, the y values are going down. So that's why we call it decreasing. And then we go to increasing. So this is a relative minimum. And again, it's relative because we have lots and lots of y values that are less than that. Okay. Okay, so we're going to be looking at how to graph a polynomial. So let's just talk about the graphs of polynomials in general. So first of all graphs of polynomials are continuous. So we say that when we say continuous, that means that there are no breaks in the graph. So as you do more and more functions, not in this class, but in future classes, you'll see that sometimes you actually have to pick up your pen when you do graphs. So continuous would be no breaks, like this. Discontinuous might look like this. Okay, there is a break in the graph then. So all polynomial graphs are continuous. And if it's discontinuous, then it would not be considered a polynomial. Okay. The next thing is that they're going to have smooth minimums and maximums. So you can see here, and in the other graphs that we talked about, they sort of curve around. If you looked at an absolute value graph, for example, that does not have a smooth minimum or a maximum. That's very pointed. So I apologize if the board work is not great right now. I'm using a new application, so it's going to take me a little bit of time to get used to it. So we have smooth minimums and maximums. So an absolute value, if you remember, looks like a V. This would be y equals absolute value of x. This is not smooth. Okay, absolute value is not a polynomial. Okay, all polynomials are going to be in the form of x to the nth. So we already know how we define polynomials. So x to the nth, it can also be called, sometimes it's called a power function, because we are raising x to a power. And the higher the power, the flatter the graph. So we can actually have some ideas what this graph looks like just from the very moment that we look at the function, that we look at the equation of the function. So the higher the power, the flatter it gets. And we'll show you what that looks like. So, and when we talk about flatter, we mean the turning points. So, for example, if we say that f of x equals x squared, so f of x equals x squared is going to look something like this. We can see that it does turn over here. Okay. If we have f of x equals x to the fourth, it starts to get flatter. And if we have f of x equals x to the sixth, it's even flatter. And I'll show you what that looks like in Desmos in a second. If we have f of x equals x cubed, so an x cubed or cubic, if n is odd, then our function looks more like this. And if we have f of x equals x to the fifth, then it's going to look, again, the center is going to be flatter. So it's going to look more like this. Okay. And let's go into Desmos and just take a look at that so that you can see what it looks like. So I'm going to just add a new window here. Sorry, again, my internet can sometimes be a little bit slow. So you can see that this is x cubed, but if we show you x to the fifth, you can see from the middle that it does actually flatten out a little bit. And if we had x to the seventh, you'd see that it actually flattens out even more. And I can expand that for you. Okay. We can do the same thing with x squared. Okay, if that's x squared, x to the fourth looks flatter. And if we did x to, let's go all the way up to x to the eighth, you can see that as it gets, as your power gets higher and higher, that the graph will flatten at its turning point. Okay. Okay, so a couple of more things about the graphs of polynomials first. So we looked at what happens to a graph as it increases as we go left to right, but now we're going to look at something called end behavior. So end behavior, we're looking at a graph in a slightly different way. So the end behavior is what's happening on the ends all the way to the left and all the way to the right. So here and here, these would be considered the ends. Okay, and we could actually determine what happens with the ends by looking at two things. We can look at the degree. So you can see that the even degree over here, when we have an even degree, it looks more like a U. Whereas when we have an odd degree, the shape of the graph is different. Okay, so if we have an even degree on both ends, each thing is doing the same. So in this case, both ends of the graph are going up. Whereas with an odd degree, they're doing opposite things. So this end of the graph is going down while this end of the graph is going up. So that's what the degree tells us. It tells us, are both ends doing the same thing or are both ends doing different things? So an even degree says both ends are doing the same thing. Whereas an odd degree says both ends are doing different things or opposite things. So when we say both ends are doing the same thing, You mean either both increasing or both decreasing? Whereas when we say that they're doing different things, we're saying one side increases and the other side decreases. Okay, and the difference here is we're not looking at the graph as it goes left to right. So in this case, what we're doing is we're picturing ourselves in the center of the graph. So imagine standing in the center of the graph. And if you look to the left, what's happening? If you look to the right, what's happening? And we're saying what happens to the y values. When we say increasing, again, we're looking at what is going on with those y values. Are they going up or are they going down? So you're saying what happens when you look left and what happens when you look right. So for example, let's say that we have this very nice graph. This is an example of a graph of a polynomial. You're going to get a better idea as to how we come to get a graph like that. You are standing right here. This is you. Okay. As you look to the right, you're going up, but as you look to the left, it's going down. Okay. So this is the up and this is the down. So we're going up here and here we're going down. Okay, so that would be your end behavior. But this isn't enough, right? Because the degree, all that's doing is it's telling us that on one end we're going up and on the other end we're going down, or on both ends we're going up and on both ends we're going down. The problem is that we don't know what's actually happening. We just know it's the same or it's different. So in order to tell what's happening, we also need the leading coefficient. So let's take a look at what is going on with the leading coefficient. So I would ask you what the leading coefficient is, but I'm not getting much of an answer from my audience right now. So I will review with you. The leading coefficient is the coefficient of the term with the highest power. So let's write that down. The coefficient of the term with the highest power. So for example, if we were to create a polynomial, f of x equals, let's say, 3, and then we'll add in the rest of the polynomial. So we have 3x to the 5th plus 2x squared minus 7x plus 1. So this 3, this is the leading coefficient. And I'm going to abbreviate leading coefficient as LC from here on out. Okay. If we had instead f of x equals this time, we'll put this in red here. So f of x equals 6 x to the 10th minus 4x squared minus 3 in this case. This one is the leading coefficient, okay? The leading coefficient is what tells us what each side is doing. So the degree tells us, okay, they're doing the same or they're doing something different. And the leading coefficient says, okay, if they're doing the same, they're rising, or if they're doing something different, the left rises, the right falls. So I'm going to create a chart with you that shows you end behavior. So we have the leading coefficient, and the leading coefficient can either be positive or it can be negative. So what's happening doesn't actually depend on the number. The fact that this is a 3 and this is a 6 is actually irrelevant. What we care about is the fact that they're positive. So the positive leading coefficient tells us what's going on. And then whether or not the degree is even or odd, that tells us if they're doing the same thing. So we have leading coefficient, and then the next thing that we look at is the degree. And the degree, what we care about is whether it's even or odd. Okay. Okay, so when the degree is even, we know that they're doing the same thing and it's positive. So what that tells us is that both sides are rising. So it's going to look like this. Okay, and you kind of already know this because of your parabola. Okay, you're all familiar with the parabola. When we have ax squared plus bx plus c, then we know that both sides rise. Okay. For negative, again, it's even. We can actually put this back in black. So if it's negative, then both sides fall. And again, you're familiar with this. It's just essentially turning it upside down. And this would be f of x equals x squared here. But we could actually have other polynomials. So one thing that you're going to see with other polynomials is that they start to develop these little humps in the middle. So for example, you might get another polynomial that looks like this. And again, we'll talk about this and how we know what's going on. So that would be another example of both sides falling. Now, if we have odd degree, we know that each thing does something different. So if it's odd, okay, we know that one side is going to rise, one side is going to fall. If it's positive, okay, if the leading coefficient is positive, the graph is going to rise on the right. It rises on the positive side. So if it's odd and positive, it will rise on the right. So remember, the right is the positive side. And it will fall on the left. So what that looks like is rising on the right, falling on the left. Looks like this. Okay, so here it falls. This is the left side. Remember that if we are standing in the center and we're looking to the left, okay, so if we're standing in the center of the graph right here and we look to the left, the y values are falling. If we look to the right, the y values are rising. And with negative, it's the opposite. It's going to rise on the left this time. Remember, the left is the negative side. And if it rises on the left, it falls on the right because they're doing something different. And this essentially just flips the graph over just like it did here, right? This one, it's pointing up, whereas this one, it's pointing down. This is the same thing. Imagine taking this graph and just flipping it so it looks something like this. So we can see over here, it falls, and over here, it rises. Okay, so if we go back into Desmos, let's just take a look at some graphs of polynomials and take a look at them. So here you can see this is negative x cubed plus 4x. So if we have negative x cubed plus 4x, the leading coefficient is negative. It's a -1, and the degree is odd. So they're doing opposite things because the degree is odd, and because the leading coefficient is negative, it's rising on the left and it's falling on the right. So again, imagine you're standing right here in the middle and you look to the left. If you look to the left, the function is rising. If you look to the right, the function is falling. If we look at the next one, the leading coefficient is positive, which means that the degree is 4. Okay, so the degree is even, which means that they're both doing the same thing on each end. And the leading coefficient is positive. It's just a 1. So in this one, the end, remember, we don't care, this doesn't tell us about the middle of the graph at all. On the ends, both sides are rising. So if we're standing right here in the center of the graph, when we look to the left, our y values are going up. And when we look to the right, our y values are also going up. And finally, if we look at one more, don't worry about these bottom graphs, we'll get to them at another time. One more, so this one, leading coefficient, let's make the leading coefficient here 4 so that you can see it doesn't really change. The leading coefficient is irrelevant, it's just if it's positive or negative. So in this one, the degree is odd, so we know that they're doing different things, but the leading coefficient is positive, which means it's going to rise on the positive side. So if we look here, it's rising on the positive side, meaning it's rising on the right, and it's falling on the left. Okay, and it doesn't matter if this is moved over. If we had done, if we changed this graph, so it doesn't matter where it is on the graph. Whether it's centered about the axis or not centered about the axis. Right now, all of the graphs that we looked at were centered along the y-axis, where the y-axis is in the center. That doesn't always happen, okay? So This is the end behavior of a graph. Okay, I think I'm going to stop this lesson here, and in the next video, I'm going to talk about how to actually graph a polynomial. I just don't want these videos to be so long. I know it's very hard to listen to. I don't want you to be too bored.